Now, part 2 of the question says, given that PQ is equal to R, determine the values of A and B. I've written down here that the determinant of P is -5 as we found in the previous work. Alright, now let's look at part 2. PQ equal R. So that means this matrix -1, 2, 0, 5 multiplied by AB is equal to 11, 15. Now multiplying the matrices, remember it's row by column. We have two rows and 2 columns in the first one, but we have only 1 column in the second. So row by column. This row by the column, the first elements, -1 times A multiplied plus the second elements 2 times B multiplied is equal to the first element in the answer 11. Alright, and then after that, next row times this column, first elements multiplied 0 times A plus the second elements multiplied, second element in row 2 is 5 and the second element in this column is B, so it's 5 times B equal the second element in the answer column 15. Alright, so what we have here is -A plus 2B is equal to 11. 0A, that's 0, plus 5B is equal to 15. 5 times B is equal to 15. 5 times what give you 15? It's 3. So B is equal to 3. Since B is equal to 3, we can rewrite this equation. -A plus 2B, but you know its B is 3, so it's 2 by 3 equals 11. So -A plus 6 is 11. Subtract 6 from both sides. -A is equal to 11 minus 6, and that 11 minus 6, not 16, 11 minus 6, which is 5. So -A is equal to +5 if we multiply both sides by -1. -A times -1 gives you a +A, and +5 times -1 gives you a -5. So what we have so far is that A is -5 and B is 3. So they asked to determine the values of A and B. A is -5 and B is 3.